Okay, so least common multiple. Okay, so what we do here, again, we need prime factorization, right? So we do 484. So we do prime factors. So it will be 2 and 2, 4, 2. Again, it will be 2, 121. And 121, we know it's 11 times 11. Right? So 484 prime factors will be 2, 11, and 11. So 496. Right? So even number we divide by 2, so it will be 248. Again, even number, so it will be 2 and 124. Even number, so it will be 2 and 62. So it will be 2 and 31. So we're done with our prime factorization. So our prime factors will be 2, 4 2s, and 31. So next number is 884. Right? So even number divide by 2, so it will be 4, 4, 2. Even number we divide by 2, so it will be 2, 2, 1. So 221. So what it can be? Let's think. 4, 5. So 13. So if we take 17, so it will be 17, 10, 15. So it should be 17 and 13. Is it right? So 170, 17 times 3 is 51. Yeah, so 17 and 13. And then, so for 884, so it will be 2, 13, and 17. So we listed our prime factors. So, and now we take unique factors, right? So we take first number, we write all factors from the first one. So it will be 2, 11, and 11. Second number, right? So we check 2, we already have, we cross it. Next 2, we already have that 2. And then we have 2 additional factors of 2, right? So we're going to write them down because we don't have them. Then we have 31. Okay? So we're done with second number. And last number, 2 we already have. Next 2 we already have. And then we have 13. I'm going to write it here. And 17. Okay. So, and now we just need to multiply all these numbers. We're not going to do it. We need a calculator. It will be. We multiply all these numbers, and we get our result. All good?
Yeah.
Perfect. So now let's try to do word problems. So applications of all this stuff. So least common multiple, real life application will be bus schedule. So right. So when we have like 3 or more buses, they have different routes. So and it takes for them different time to run all the route, right? So, and we want to figure out when all buses will be together at the same bus station, right? So if you need connections, right? So if you take one bus and then you need to connect to another bus, right? So, and this is how it's done. So they use least common multiple for these bus schedules to optimize buses. We'll get these type of questions later, but let's do question 4. Necklace has 3 strands of beads. Each strand begins and ends with a red bead. If a red bead occurs every 6 beats on one strand, every 4th beat on the 2nd strand, and every 10th beat on the 3rd strand, what is the least number of beats each strand can have? Okay. So we have 6. So we have 6, then 4, and 10. Every 4, every 6, every 10. This has 3 strands of beads. Each strand begins and ends with a red bead. If the red bead occurs every 6 beat on one strand, every. Okay, so how to do it? And so it will be least common multiple, right? So prime factors. For 4 it will be 2 and 2. For 6, sorry, I'm gonna write. So 2 and 2. For 6 it will be 2 and 3, and for 10 it will be 2 and 5, right? And so this question is least common multiple. So we have, right, from first one we write down all factors, so it's 2 and 2. Second one, so we already have 2, right, so we're not going to take it, but we're going to take 3. From this 10, we already have 2, we're not going to take it, but we're going to have 5, right? So if we multiply them, so what we're going to get, it's 2 times 2, 4 times 3, 12 times 5 is 60. So the smallest number of bits we're going to have is 60. Okay? Questions?
No.
Okay, so let's do question 6. How do you know that the area of each square is perfect square? Determine the side length of each square. Okay, so we have, so it's a next topic, but again, this topic is built on top of what we just learned. Prime factorization, least common multiple, and greatest common factor. So now we need to figure out, so we have a square, and area of the square is 784 inches squared. So how can we prove that this is indeed a square? Okay, so we know that square has all sides equal. So each side has the same length. And we know that area of the square is, if we say that each side is a, it will be a times a, or a squared. So how to figure out the length of each side? Prime factorization. Right? So we do prime factorization first of 784. So it will even number divisible by 2. So it will be 3, 18, 9, 392. And again by 2. So it will be 1. Then 19, it will be 9. And then it's 12. So it's 6. 196, again, even number. So it's 2. It will be 98. And again, it's by 2. And it will be 49. And then 49 is 7 times 7. Right? So, how to figure out if this is perfect square or not? So because perfect square, so each side we have two identical factors, right? Two numbers, a and a. So what we need to do, we need to group these prime factors that we just found. So we have 2, 2, 2, 2, 7, and 7. So we need to group them into equal groups, right? So it's obviously we have 4 2's and 2 7's, right? So it will be 2, 2, and 7, one group, and we multiply them. And second group will be again 2, 2, and 7, right? Because it's multiplication, right? Prime factors. It's a multiplication. So we can regroup. We can multiply in any order we want, right? And what do we get? 2 times 2 is 4. 4 times 7 is 28. Uh, 28. And in second group, we have 28. And now we've got two identical factors. And it proves that this shape indeed is a square with side length of 28. Right? So it's 28 by 28. So and this is what we need to do, right? So we needed to show that 784 is a perfect square, right? To show that it has two identical factors, right? And we found 28 times 28. Okay, so let's try to do next question. So we have to prove the same. So we have a square. Oh, well, we don't know yet if it's square or not. So we have a shape. It's probably too high, you don't see it. So we know that area of this shape is 1024 centimeters squared. Right? So we want to show that this is indeed square. So if it's square, so it means that it has all sides of equal length. Now we need to show it. So how we do it? Prime factorization. Right? So it's even number, so it will be 2, 512, 2, 256, 2, 128, 2, 64, 2, 32, 32, 2, 16, 2, 8, 2, 4, and then 2 and 2. So what we've got here, we've got 10 2's, right? So 2 times 2 times 2 times 2 times 2, so it's 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So if we multiply 10 2's, we'll get 1024, famous number for people who deal with coding. And what we need to do to group, we need to group these factors into two groups with equal number of factors, right? So because we have 10, we can group them by 5. By 5. And what do we get here? So 2 to the power 2 multiplied 5 times, it will be 32. And in the second brackets, so we get 32. And here we go. We proved that this is indeed a square with side length of 32. All good? Questions?
Can you do one more, please? Like just this one.
Okay, let's do more of this. So next level, it will be to prove that shape is perfect cube. Right? So it will be a little bit more complicated, just additional layer on top what we just did. Okay, let's try another example. What we can use. Let me think. What number we can take? Just give me a second to think. Yeah, 900. This is okay. Let's take not hard one. So we have a figure, area of 900 centimeters squared, right? So we need to prove that this is perfect square, that this figure is a square. Okay, so we need to prove that these side lengths are equal. So again, we know that if this figure is a square, it must have side lengths of equal size, right? Because area of the square is a times a. Okay, so 900, we do prime factorization, so it will be 2, 450, 450, so it will be 2, then it will be 225, then it will be 5, and it will be 45, then again it will be 5 and 9, and then 3 and 3. All good up to here? So now we list our factors. 2 times 2 times 3 times 3. So we have 2 2's, 2 3's, and 2 5's. So now we want to group them in two groups, right? Because we must have two identical factors. So we need to group them into groups with same number of factors. I mean, in one group we should have factors, and in the second group we must have same factors. And we can see that each factor we have twice, like 2. So we can group them as 2 times 3 times 5 will be one group. And second group will be 2 times 3 times 5, right? Will be in the second group. And what do we get? 2 times 3 times 5 is 30, and in the second bracket we get 30. So our side length is 30, so we have square 30 by 30. Good?
Yes, yeah.
Perfect. So now let's do with cube. So same idea, we'll have 3 groups instead of 2 because it's perfect cube, right? And volume of the cube is length times width times height. And because all sides are equal, so we will have 3 identical numbers, right? So next, exercise 7a. So we have shape. We don't know if it's cube or not. But we know that volume of this shape is 1,728 centimeters cubed, right? So volume is A, so if it's cube, so all sides, all edges must be equal, right? So, and we want to show that this is cube. Okay, same process, prime factorization. So 2, right? So it will be 16, so it will be 8, then it's 12, it's 6, and then 4 is, and then it's 4. Okay, we continue. So again, even number, so it will be 2. I should probably write it smaller, so we have enough space on the board. So it will be 2, 8, 6, 4. Then again 2, so it will be 4, 3, 2, 432 again by 2. So it will be 216. Yeah. Sorry, my mental math skills need to work on them. Okay, so it's 2 and 216. Then by 2, it will be 108. Then by 2, it will be 54. Then by 2, it will be 2 and 27. 27 is 3 by 9. And 9 is 3 by 3. Here we go. Now it's better. So 1, 2, 3, 4, 5, 6. So we have 6 factors of 2. And 3 factors of 3. So now we need to group them into 3 groups, right? So 2, 2, 2. Then we have another 2. And then we have 3. Okay, and what do we get? So 2 times 2 is 4 times 3 is 12. So we have 12 times 12 times 12. Okay, so our shape is cube with edge length of 12. All good?
Yeah.
Okay, let's do one more. So now we want to show that that this is a cube with volume 2,744 centimeters cubed. Okay, same procedure, prime factorization. So 2, 1, 3, 7, 2, be 2, then it will be 6, 8, 6, and it will be 2, 3, 4, 3, 7, if we, so it will be 7, so 7, it will be 28, so it will be 49, and 7 and 7. So here are our prime factors. So we have 2 times 2 times 2 times 7 times 7 times 7. And again, we need to group them into 3 groups with identical factors. So it will be 2, right, and times 7. And what do we get? We get 14 times 14 times 14. Okay, so, and we have cube with edge length of 14. All good?
Yeah.
Okay, we can finish for today. And I'll see you Wednesday.
Yeah.
Okay.